All right, so now we're going to talk about a powerful tool in solving equations and frankly mathematics, and that is the least common multiple. So you found this before when you were dealing with maybe something like this where you had where you had something like 2/3 plus 7/8, okay? And if we want to add these up, we know that we need a common denominator to do that. Well, I know that both of these numbers divide into 24. That is a common multiple of them. It happens to be the least common multiple. And we'll get into the fact that least is actually not that important. Usually you just need a common multiple. Okay? And then we could use the identity property to say that 8 times 3 is going to give me that 24 that I want. So I'm going to multiply by 3 over 3 since that's equal to 1, not changing the value. And on the top here, I need to multiply 3 by 8 to get 24. And so I'm going to multiply by 8 over 8, which is of course also equal to 1. Okay, and again, hopefully you feel pretty comfortable with this. And now we can add them up, but that's not the concern here. Just trying to get you to remember this. But just keep in mind, we don't really usually need the least common multiple. It just means we generally won't have to do as much reducing at the end, okay? So how could we do this in a more interesting problem? So what if we had something like this? Well, I don't know about you, but solving this in its current form is going to be more trouble than I really want to handle, okay? So I'm going to show a little trick. If we multiply by a common multiple, okay, and it doesn't have to be the least common, just a common multiple, all these fractions are going to go away. And the trick I really want to show you is that if we just take all of the denominators, okay, and multiply them out, and I'm actually not going to multiply them out completely, okay, that's a common multiple. 3 will go into it, 4 will go into it, and 7 will go into it. But if I do it to one side, I have to do it to the other. So now I'm going to distribute and multiply everything out. All right, now you'll notice I left it as 3 times 4 times 7 because it's actually easier to cancel things to 1 if we don't multiply them out. Because here I clearly have the 3 over 3, which I know is equal to 1. I have 4 over 4, which is equal to 1, and 7 over 7, which is equal to 1. And then I can rewrite everything back out, multiplying everything together. And now, while some of these numbers are a little large, it's really not going to be that hard to solve. And so I'll just go through and solve the rest, and we'll see what our solution looks like at the end here. And I wanted to show you this answer just to remind you that not all these answers are going to work out nice. And this is actually a perfectly legitimate answer. We could plug it back in, although maybe a little later I'll show you a quicker way of doing that since plugging this in would be kind of a pain. But now let's go ahead and look at an example that is a little more algebraic. Cool. So now the trick I showed you before will work just fine here as well. I'm going to multiply by a common multiple, and I'm just going to take the 3 and the x plus 1 and multiply by that, because I know that both 3 and x plus 1 will definitely go into it. And I'm going to do a little bit of canceling. X plus 1 divided by x plus 1 cancels to 1. No distribution in this case. 3 divided by 3 cancels to 1. And now I can multiply everything back out. There we go. And now, again, while we got kind of, not a real funky answer, but a little bit of a funky answer, the solving itself was a lot easier once I multiplied by a common multiple to eliminate those denominators and cancel them to 1.